Welcome again. In this lecture, I'm going to show you why do you need to use iota and what is it about. Let's start. Let's say that you want to declare constants that represent the days of the week. This way, you will prevent the magic numbers in your code. Alright? So each day will be represented with a unique number. To do that, you need to initialize the constants with increasing numbers for each day or they will clash. First, let's multi-declare a few constants for the weekdays. The first one is Monday and its value is 0. The second one is Tuesday and its value is 1. As you can see, I am increasing the numbers one by one for each constant. And it goes like this until Sunday. Okay, now let's print them. Okay, let's run it. This prints the numbers from 0 to 6 as expected. Because I know about the features of Go, typing it like this looks unnecessary to me. In a second, you will also think the same thing. It's because Go can do this for you. Let's check it out. As you can see, I removed the constant values. Now you're gonna learn how to use the iota, the number generator for constants. Let's initialize the first constant with iota now. Okay, let's run it. As you can see, it prints the same output just like the previous example. So how does this work? Is it magic? Yes, it's magic. It uses the following features of Go. First, constants repeat the previous constants, type and expression. Second, iota, the number generator for constants. As I said, iota is a number generator for constants. Think of it like an ever-increasing automatic counter. For each new constant here, iota will generate a new number automatically, because each constant will repeat iota as its initial value, as if they've been initialized with iota. So iota will keep increasing itself. Monday's value becomes 0, because iota starts at 0. And Tuesday becomes 1, because Go increases the iota for each constant. And Wednesday becomes 2, iota keeps increasing. Thursday becomes 3, Friday becomes 4, Saturday becomes 5, and lastly, Sunday becomes 6. And after the multiple constant declaration ends, Go resets the iota. So if you use it within another constant declaration, it will start from 0 again. As you can see here, iota keeps increasing automatically for each constant. So behind the scenes, constants repeat iota. This happens because a constant repeats the type and the expression of the previous constant. Let's take a look at another example. As you know, you can use expressions when initializing constants. Since iota is actually a value, so you can use it within a constant expression as well. Let's check it out. As an example, let's add 1 to iota while initializing the Monday. Now this expression just adds 1 to iota and generates a new value before assigning it to the Monday constant. So what do you think about this? I mean, what values these constants will get when I run this? Pause the video now, think about this for a minute or so, then continue. Okay, let's run it now and find out. As you can see, this time the result is different. Instead of starting from 0, Monday has started from 1, and others have followed it. Now let's see how it works. At first, iota starts at 0, but the expression is iota plus 1. So Monday becomes 1 instead of 0. And Tuesday repeats the previous expression and it becomes 2. It's because iota is 1, but the expression is iota plus 1. Then iota becomes 2 and Wednesday becomes 3. After that, iota becomes 3 and Thursday becomes 4. Next, iota becomes 4 and Friday becomes 5. And iota becomes 5 and Saturday becomes 6. And lastly, iota becomes 6 and Sunday becomes 7. As you can see, each constant repeats the Monday's expression. So each constant repeats iota plus 1 expression. Using an expression with iota depends on your imagination. It can be very powerful. For ideas, please check out my blog post about iota. It contains a lot of tips and tricks. I attached the link in the resources for it. Now let's take a look at how to use the blank identifier with iota. Remember, the blank identifier is like a black hole which eats values without any point of return. Let's check it out. Let's say that you want to declare constants for representing a few common time zones. Let me show you the time zones table first. EST here means Eastern Standard Time. It is 5 hours behind of UTC. By the way, UTC means Universal Time, and MST is Mountain Standard Time, and it is 7 hours behind of UTC. And lastly, PST is California Standard Time, and it's 8 hours behind of UTC. So according to this table, how should I declare the constants? Let me show you. Let's first declare constants using a multiple constant declaration. I'm going to declare 3 constants which will represent the time zones. According to the table, EST should be -5, and MST should be -7, and PST should be -8. So let's declare a constant for EST as -5. Then let's declare another constant for MST, it should be -7. And lastly, let's declare PST, it should be -8. Okay, great, now print those constants. Okay, let's run it. Okay, now let's suppose that the actual time zone table is much more longer. If so, then it's better to use iota. But how can I do that? Let's figure it out next. Now I've removed the initial values from the constants. That's because I want to replace them using iota. In the meantime, I've calculated a formula. Or actually, I stole it from one of the Go examples. Let's try it with iota now. Now follow the boxes next to the constants. I'm going to display what my formula computes for each constant. So according to my formula, EST will be -5. Great, my formula works. Let's look at MST constant now. According to the time zones table, it should be -7. Let's check it out. It looks like my formula has calculated it as -6, but it should be -7. Bummer, so my formula doesn't work. Let's continue for now. Let's look at PST constant this time. It's incorrect as well. My formula returns -7, but PST is -8 on the table. So my formula definitely doesn't work. Okay, let's run it. Compare the output to the time zones table. You'll see that the program's output slips -1 hour. So to solve this problem right on this line between EST and MST, I need to increase iota without declaring another constant here, right? So if I do that, then the constants will match to the time zones table. Let's do that now. Now I've moved MST and PST constants one line down. Now I'm going to add a blank identifier right between the EST and the MST constants like this. Let's recalculate the values again. Let's start with EST. Iota is 0 now, so if I put iota into my formula, it becomes 5 plus 0, which is 5, and when multiplied by -1, EST becomes -5 now. Cool, it's correct so far. Now let's take a look at the next line. Iota will keep increasing here, so the formula looks like this. 5 plus 1 multiplied by -1 is -6. This value will be assigned to the blank identifier. Remember, the blank identifier is like a black hole. What you send into it will disappear. Okay, now let's take a look at MST. 5 plus 2 multiplied by -1 is -7. Good. According to the time zones table, this is also correct. And lastly, take a look at PST. 5 plus 3 multiplied by -1 is -8. So this is also correct. As you can see, by using a blank identifier, I can adjust the values of the constants correctly. I used the blank identifier only for increasing the iota, and I didn't use it ever after. So you can use a blank identifier and iota to adjust the values of your constants too. Perfect. Alright, that's all for now. Thank you for your patience. See you in the next lecture.